So good morning, everybody, and welcome to this event. So my name is Miles Upton. I am the General Manager for Cambridge Consultants in APAC. So first of all, congratulations for finding the venue. It wasn't easy, so I appreciate that. I think let us get moving, and please, I'd like to welcome Susan Oliver from the British Embassy. Here you go, Susan.
Thank you. Thank you, Miles. Hajime shite watashi wa Susan Oliver desu. My first paragraph is to introduce myself. Miles has done it beautifully for me, so thank you very much indeed. It's my pleasure to welcome you to this important forum today, hosted by Cambridge Consultants. Cambridge Consultants is one of the UK's premier technology consulting firms, driving innovation across multiple sectors through partnerships with its clients. Over the past 65 years since its establishment as one of the founding members of the Cambridge Technology Cluster, the company has brought UK innovation to the international arena with its world-leading expertise, including in Japan. As a representative of the UK government, I am delighted to support this event, which aims to strengthen UK-Japan collaboration in the new space economy. Today's focus on international collaboration in the space sector comes at a critical time. We are experiencing unprecedented innovation, from advanced satellite services and orbital infrastructure to climate monitoring technologies, space situational awareness systems, and pioneering in-orbit manufacturing capabilities. The reality is that space innovation requires global partnerships. Transitioning from concept to orbit demands a comprehensive ecosystem spanning regulatory frameworks, infrastructure development, investment channels, and world-class engineering expertise. This is precisely why partnerships like those we are supporting today are so essential. The UK has made a firm commitment to building this ecosystem. Our modern industrial strategy specifically identifies advanced manufacturing as a priority sector, with space designated as one of its 6 frontier industries. This commitment is backed by an £80 million investment package and a new critical investment framework. Crucially, we recognise that international collaboration lies at the heart of realising our ambitious goals. And we see Japan as an ideal strategic partner. From the Hiroshima Accord to the UK Space Agency JAXA Memorandum of Cooperation, we are establishing robust foundations for long-term space collaboration across policy, commercial, and security domains. Companies like Cambridge Consultants are at the forefront of this, addressing complex challenges facing the global space ecosystem. As we consider future developments, we must acknowledge that space sustainability requires multinational cooperation. And in today's increasingly congested orbital environment, the UK is dedicated to working alongside international partners like Japan to ensure that space economy remains safe, secure, and sustainable for our future generations. The panel assembled this morning brings together distinguished leaders from government, industry, and research sectors. I hope these discussions will catalyse creative thinking, foster new collaborative ventures, and accelerate the UK-Japan cooperation in space. Please let me assure you that the UK government stands ready to support these initiatives through trade promotion, policy alignment, and facilitating connections between UK organisations and Japanese partners. Please do reach out if we can assist in developing any of your partnerships in the space sector. Thank you for your attention this morning. I really am looking forward to the discussions that will follow. Thank you.
Thank you very much, Susan. That was excellent and really appreciated. So we'll now move straight into our panel session. So there is the speakers are here, but we'd like to start by asking the speakers to introduce themselves. So please, Yamamoto-san to start.
Hello, everyone. Very excited to be here today with the prestigious panelists here today. I am Yohei Yamamoto, VP of Strategy in Space Corporation. And our company is only 3 years old. We are founded by 2 companies, NTT, Japanese biggest telco in Japan, and also Space Sky Perfect JSAT Corporation, which is a traditional geosatellite operator. So our company has a mission called Space Integrated Computing Network, where we integrate all the LEO, GEO, HAPS, high altitude platforms, all those networks by traditional radio access, and also with latest cutting edge technology, optical communications. So, and we are working with a lot of international companies like UK, US, and Europe, all over the world. So very happy to be here today and looking forward to the discussions.
Thank you, Yamamoto-san. And so, secondly, Wakata-san, some people in the audience may know him, but please introduce yourself.
Ohayou gozaimasu. Good morning. Thank you, Miles, for the introduction. My name is Koichi Wakata. I am an astronaut and Chief Technology Officer of Axiom Space. I joined this organization, the company, about a year ago after working for Japan Aerospace Exploration Agency for 32 years. And it's a switch from government-supported human space activities to completely commercialized exploration in space. So I'm in charge of the Asia-Pacific region, but at the same time, as an astronaut, I support the development of a new space station, Axiom Station, which will be launched no earlier than 2027. That will be a replacement of the International Space Station that is flying on orbit, which is going to be commissioned in 2030. And we're also building the new spacesuit that will be used on the surface of the moon. Actually, about a month ago, I was in the pool for 6 hours developing the new spacesuit for the lunar mission, which will be used on the Artemis 3 mission in 2027 by the U.S. astronauts. And also, we are flying human space flight, commercial human space flights to the ISS. We have already completed 3 missions in the last 3 years. And the latest one, the 4th mission, AX4, is currently on orbit for about 2 weeks. We have a first astronaut to go to the International Space Station from India, Poland, and Hungary. And we are expanding this door to more nations that are not part of the International Space Station program to utilize the ISS. And then also, as a space infrastructure company, we're building the framework of the orbital data center. Space Compass has been a leading company in that aspect as well. And I hope we will be able to work with UK government and also industry in this aspect. I had a chance to work with Tim Peake, UK astronaut in Houston when I was assigned as an astronaut office. And I hope we will continue to work with the UK, Japan, and many countries in this field. Thank you very much.
Thank you, Wakata-san. Please, so Tania, please introduce yourself.
Yeah, thank you. Good morning, everyone. I'm Tania Celani. I am absolutely delighted to be here today and with such fantastic panel members as well. I am neither an astronaut nor do I work in a space company, but I am Deputy Director for Space in the Department for Science, Innovation and Technology. I'm responsible for our international strategy, so our strategic approach to bilateral and multilateral cooperation on civil space, for security and resilience, so to ensure that the UK space sector continues to remain resilient, for regulation, so again, ensuring that the UK has the right flexible regulatory regime to support operators in the UK and to work with international partners as well. So the Space Directorate in DCIT is the lead government department in the UK government for civil space strategy and policy. We sponsor the UK Space Agency. We provide the budget to the UK Space Agency, and we work very closely with them as they are our delivery partners. We also play a coordinating role in the UK government. So as all of you know, space touches so many different areas, affects us every day in everyday life. So really our role is to coordinate and cohere things across the UK government to make sure that we're talking to departments who may not even know they should be interested in space as well, and really ensure we take a much more coordinated one government approach to growing the space sector and importantly, to enabling the wider economy as well. Thank you very much.
Thank you very much, Tania. So, Ian, please introduce yourself.
Good morning, everyone. You hear me in the back? Is it working? Good. All right. Good morning. My name is Ian Christensen. Thank you all for joining us today. I'm looking forward to interacting with the audience and with the fellow panelists. I work for an organization based in the United States called Secure World Foundation. Secure World Foundation is a nonprofit organization, a non-governmental organization. We focus on the issue of space sustainability and doing research and facilitating and coordinating dialogue around space sustainability. So for us, space sustainability is how do we as a global society continue to access and use space and ensure the environment is stable so that we can benefit from the applications that space technology and services provide. So stability of the orbital environment, but because it benefits us here on Earth. And within that portfolio of space sustainability, we've worked on a wide range of issues. So we consider space security topics and dialogue and transparency efforts around space security as part of the space sustainability challenge. We work on governance questions. We work on benefit policy and access to data. And then my area is the emerging commercial space industry and what responsible and sustainable use of space in the industry context means. So that includes things like space situational awareness mentioned earlier, space debris mitigation, and then also just the general context for safe operations in industry. So thank you and look forward to the discussion.
Thank you very much, Ian. And last but not least, Mori-san.
Hi, good morning. おはようございます。I tend to speak Japanese. I'm Hiro. I'm Group Chief Strategy Officer of Warp Space, and also CXO advisor at the Spacetide conference. And you probably know the Spacetide. This is a main event, and I've been helping CXOs. But I'm here as Warp Space, and Warp Space is a Japanese startup focusing on laser communication technology. Our vision is launching a MEO constellation utilizing optical laser communication. We will have some little bit of a discussion later on. And not just like a constellation, we have several hardware and software technologies to enable other satellite operators to use various optical communication technologies. And we've been expanding globally. Headquarters in Japan, but we have an office in Europe and US, and we do hope to work with the UK government or companies as well. And I'm definitely looking forward to have a more better discussion here with other potential collaborators here. Thank you.
Thank you very much, Mori-san. Sorry, I did forget one thing in my introduction, which is the aim is we will finish about 11 a.m. thereabouts, depending on the Q&A. But afterwards, we will have refreshments here, and there will be networking. The speakers, I think, will all stay. So if people have questions they want to address to particular panelists after the event, we can cover those at the end. So please stay at the end for some refreshments and some questions. Okay, so let's get started. So I'm going to start with a question to Mori-san. So obviously we're seeing this explosion in new markets, new use cases. You mentioned one, building optical networks in space. So where's the biggest opportunity in space at the moment?
Sure, yeah, it's difficult question, and it's
Yes.
depending on location. It could change, and also depending on application. But my generic view, since I tend to work in Europe, US, and Japan, optical communication obviously it's becoming a big trend last 3 to 5 years. Because the reason is basically the amount of data generated in space is increasing. Obviously, in order to contribute to say our society, we need to get the data from space asset. Then one solution was changing the frequency from radio frequency to optical communication. This is kind of obvious. And also technology is getting mature last 2 decades. Like Europe, Japan, and also US has been developing this technology. It becoming more commercialized. And other than that, also frequency is depleted. In order to do the satellite communication, you have to do the coordination with international organization. And optical communication can avoid all these paperworks. And those issues are actually some of the reasons optical communication getting a hot trend. Other than that, I think Ian can mention more, but space SSA, space domain awareness, space situational awareness has been a big trend as well globally, and also in Japan as well. And one of the company in Japan actually is being the leader. Well, maybe you can mention this, mention about this company later. But other than that, human space activities, including a space station, definitely has been a big trend. And well, there are other applications like we tend to say that in-orbit solutions, which includes like in-orbit computation or AI, like a kind of edge AI solutions. Some of the panelists are working on this. I think those topics are major topics discussed globally, and also same in Japan. Yeah.
Okay, quite a lot to cover then. We only have an hour, so let's see. Let's go. So Ian, I mean, obviously your role, how will that overlap with what Morris-san just mentioned?
Yeah, so I think Morris-san, you highlighted something that is the complexity that we're seeing in the space in this year.
Is your microphone working? So if we stop with
Oh, we have more microphones than speakers. That's a good arrangement. Yeah. So Morris-san, I think in your remarks you inadvertently, I think, or maybe intentionally highlighted the complexity that we're seeing in the space sector right now. There's a lot of change. There's a lot of new applications. There's a lot of new things going on, right? And so that's I think it's a cliche, but the opportunity and a challenge in that, right? And then we have to figure out how to navigate that. So space is a few characteristics of space, right? Space is harsh, right? We know there's a lot of natural and human-created hazards in space. Wakata-san and others, you've lived that in reality, right? It's a remote environment. Space is a strategic domain, right? There's economic, national security, and diplomatic interests in what we do in space. And space is a shared domain. So actions that any one actor takes, be that commercial actor, governmental actor, et cetera, might affect, for better or worse, the other actors in that domain, and we can't escape from the very shared nature of this domain. So the risk, I think, is as the domain becomes more complex, as we grow in actors and activities, that these three characteristics interact and might mean that we have more of a challenge to access and use space, and we have to think about how we address that complexity. I mean, how that challenge or risk might demonstrate or validate is that costs of operations might go up in a way that becomes too difficult or too costly to operate in space unless you're one of the very established actors. And it might be, you might see increasing competition and even maybe more direct state-to-state conflict in space, right? So those kind of risks do exist. And how do we mitigate that? Partnership is important. I think we're going to talk some of that, but partnership allows us to share infrastructure, reduce costs that way. It allows us to set operational and business norms that we all follow and set some stability in the domain, and it provides resilience, right? And it also increases access. So I think AX4 is a great example of how partnership and commercial capabilities can increase access, right? So I think those are some of the trends that we're balancing, and hopefully we can get into that a little bit more in this discussion.
Thank you. Yeah, I think financing and cost is probably something we should come back to, because I think there is an issue around what's driven the explosion in space, and where is that going to go? So Tania, what would you say?
Yeah. So I think just to echo and emphasize some of what Morris-san and Ian have said, space is really undergoing a really rapid transformative change. So really there are opportunities across so many capability areas. We just look at the number of satellites. You talk about the explosion. Can you hear me?
Yeah, I'm just checking the microphone.
Can you hear me now?
Yeah.
Okay, sorry.
Okay.
As we just look at the number of satellites going into space, so from around 10,000 earlier this year to 60,000 by 2030, and really the rapid pace of technological innovation as well. So we talk about costs. So the cost has come down of going to space, increased private capital investment as well, and really the reusability of things in space. So the trend that is growing there as well. And as Morris-san said, a really unprecedented demand for space data. I think that will only grow, and really for connectivity as well. So some of the opportunities and technology areas that I'd highlight, So ISAM technology, so in-orbit servicing, assembly and manufacturing, really a key technology there to ensure space sustainability, so really to counter the contested, congested space environment. In the UK, we have made investments in Astroscale and ClearSpace, and recently launched a big procurement last week for a national active debris removal mission as well. The use of Earth observation for climate resilience. We see the Truths mission, the ESA mission, which will calibrate data from satellites, crucially important. And again, launch, which is a particular area that the UK is interested in. So with the reduction of launch costs, a more diverse, competitive ecosystem, really, we can see the use of launch, not just for civil, for connectivity, but also for disaster management, a particular issue for Japan, we know, but also for the military side of things as well. There's probably plenty more I could talk about space domain awareness and the importance of monitoring and tracking and knowing what's out there. But those are a few areas I would draw upon.
Okay, thank you. I think there's an interesting aspect there, which is the shift between government and private sector. And maybe Wakata-san represents this very well, having moved from government into private sector. But what would you comment on?
Yeah, I think now is the time, because I think it's a very important opportunity for us to advance human presence in a commercial manner. As I mentioned, the ISS is going to be operated for another 4 or 5 years. In 2030, it's going to be decommissioned and will fall down to the Pacific Ocean. And I think seamless transition from this government-led the International Space Station to the commercial sector for the LEO is very important for permanent human presence. And we will be able to do a lot of things, including the in-space manufacturing and orbital data center, utilizing the human asset. And so Ian mentioned that it's very important to have this resilience. I flew in space 5 times. Each time when I flew, we did a variety of debris avoidance maneuvers. It seems to me that the number of avoidance maneuvers is increasing. When I was on board the station about 2 years ago, we did like 4 or 5 avoidance maneuvers. And it's a huge threat. And so in order for us to be able to safely stay in orbit, I think we need to have a framework that would work for many countries, collaboration. And that's why I think Cambridge consultant and those organizations help or work as a bridge between the government, industry, and academia to secure the resources of the people, engineering, and then to lead to a solution to tackle those very fundamentally very critical and challenging tasks.
Thank you very much. Yamamoto-san.
Sure. I'm just echoing Mori-san and Tania's comment about space data explosion. I think we all know that data is exploding, and I think we're very close to the tipping point where the data becomes value, and those data delivered to the right time, to the right people. And I think we can't ignore but the power of AI accelerating so rapidly that we think, right? And those data is going to have real value. It's going to be really like a GPS we use. It's going to be essential, inevitable. We can't live without it. I'm very confident that space data is going to be something like that. And I think those demand, of course, the space is hard, and of course we are going to fail at some point. But I think with the international collaboration with these prestigious people, I think we can overcome by this huge upcoming demands. So I'm very optimistic about it.
So do you think we could have too much data?
Too much. I'm sure AI goes to handle that. I mean, I think we already have a lot of data, but it's still we don't have a value. Yeah, we don't have a means to value, make it to the value. So, yeah, but I think it's really getting there right now.
Okay, so do you see therefore the data is available, but the applications are still emerging? Would that be what the panel would say? Ian, you smiled at that point, so maybe.
Well, so I think there's a discussion that can be had about data versus information.
Yeah.
Right? So I mean, we can collect a lot of data, but it's not useful until you can use it and do something with that. So that's a challenge that we have in the space situational awareness community right now, is that there's large catalogs. We're collecting a lot of data, but the operators need to be able to how to use that to make safety decisions, right? And so if you're talking about this explosion of applications data or other data collected through space, it's great to have it, but until you can get it to the right people and they can relate to it in a use case, that I think is a more of a challenge that's coming than just about the raw amount of data that we have.
Okay. Yeah, please.
Yeah, I think there's a huge difference between data and information, right?
Yes.
And that's why I think it's even more important for us to have orbital asset like orbital data center, because a bunch of those satellites, gather all kinds of information. Data.
Yeah.
Probably, I don't know what's the percentage, but much of the data is not used because with this, Starlink and also optical communication, we have a, pretty fast data transmission between the satellite assets, but between the satellite, the LEO, MEO, from GEO to the ground, most of the time it's a RF frequency,
yes.
And it depends, because optical asset really depends on the weather condition, and that's why if we have an orbiter data center that can, be the core of the computing real time, summarizing the data for useful information. And I think it's getting more and more important to have the orbital data types asset, and that is also very important for security and also the resilience. And as a backup to potential cyber attacks on the ground asset, if we have an orbital asset like orbital data center, that can serve as a backup system to the ground system.
Okay, thank you. I think that's quite interesting. That feeds into the next question. So, Tania, you talked about climate, security, sustainability in your opening. So, where will space play the biggest part across those three domains? Is it equal? And maybe Ian, do you want to go off on?
Okay, well, is it equal? That's an interesting way of phrasing that, because I think space has a role to play in all of those domains. I think right now I would say we're seeing a lot of emphasis on space as a enabler and asset in security right now. I think that is a dimension that in the current geopolitical trends, current market trends, that we're really seeing governments come back and rely on space systems as a security tool, industry seeing value in providing services that relate to security. So I think we're seeing an emphasis on security right now. Climate, space clearly has a big role to play in how we monitor and respond to dynamics in climate change and in the environmental in the environment itself. One of the challenges I think that we at Secure World see right now, space clearly contributes to our knowledge about the changing climate and about environmental factors. We're also seeing a public discussion about is space really providing that benefit, and are we maybe spending resources on space, and we could be spending those resources responding to climate change, right? So how we as a community can tell that story of benefit and make that use case really relevant to the general public, I think is a challenge that our community faces right now.
Yeah. And I think the national security element, if we look in the UK, where we really want to prioritise going forward on space, it's really national security and economic growth. Those are the two things that are governing our current strategic direction on space in the UK. And we see that in the current conflict. The use of space, I think, has just brought things really to the fore in a way perhaps people previously hadn't really thought about. And the dual use of space technologies, I think that comes back time and time again, the potential to use those technologies for both purposes, to keep people safe, but also to provide the data, as we talked about, for climate change as well. So certainly a role there for space in all of those. And I think the other thing that I always think about is non-space sectors. So the use of space and the benefits for non-space sectors, I am really keen that we just don't talk to ourselves, but that we're talking to the other sectors. The future of, manufacturing in space, for the pharmaceutical industry, for others. I think that is where we are increasingly going to go to. We should be talking to.
Okay. I think there's the link there from effectively Ian referred to the political need to inform the population about why spend money on space when there's so many demands on the ground. Maybe Mori-san or the other Japanese delegates can comment. From a Japanese perspective, resilience has been a need. It's almost a social need for a long time. So is it easier here to tell the story of space and why you should invest in it? Or
Well, my personal opinion, it's like I think it's compared to Europe or US, maybe it's relatively more difficult. It's like history of like self-defense, etc. Those are also one of the I think the focuses. But if we discuss about the actual budget, I think probably people here may have heard about a Japanese space strategy fund. That's non-defense. But also, if you talk about a defense budget related to space, also $2 billion increase, roughly. So it's like trend is actually quite similar to US and Europe. I think, utilizing space asset to increase this, national security bit is being discussed and it's actually happening. So, but coming back to your question, I think it's experience by like a Japanese national security members of like space asset is compared to I think Europe or US is slightly less for now. So I think it's been a bit difficult for commercial player to talk with the Japanese government. That's I hear sometimes.
okay, I think maybe Yamamoto-san, I don't know whether you'd like to comment on that one.
Yeah, I think it's a bit difficult, but I think there's a trend of the understanding of space importance has been increasing a lot, represented by JAXA funding, strategic funding. So but I think national security is of course important issue, but that's a disaster preventions and those issues. I think there's a tremendous importance there as well. So. I think the awareness is increasing in Japan, and hopefully we can continue.
Wakata-san, do you have any comment on Japanese?
Sorry. I go ahead. Can you hear me? Can you hear me?
Yeah.
Yeah, sorry. Yes, I echo everybody. And I think a key theme here is that, of course, space economy is important and national security is very important. But I think I think the theme of this dual utilization. Dual means it's not only the civil and the military or defense. That's very important to utilize all the assets and the budget in a very efficient manner. But at the same time, dual utilization between space and the ground. So I think still, we have a lot to explore to economize our activities in space. But if you combine the technology, the results of the space exploration too are a benefit of new enhancement of a technology for the ground. For example, like JAXA and Toyota Corporation are working on the development of the new lunar cruiser for the exploration on the moon. By having this technology, the ground the technology with the space technology, I think the outcome could be beneficial for both the space and underground operations. So dual utilization between civil and defense, as well as space and the ground, those are key targets, I would say.
Okay, good. So I think if we talk about collaboration is difficult without frameworks. So maybe, Tania, would you like to comment on how do governments set frameworks for collaboration?
Yeah, so delighted to talk to that question. So we've got the Outer Space Treaty, don't we? That provides kind of the baseline for peaceful cooperation and data sharing. In the UK, we are very active at the UN Committee on Peaceful Uses of Outer Space, so COPUOS, where really that's where countries get together. We look at standards, we look at governance, we look at regulation for space for the future. And we have to remember, so even in the UK, our regulatory framework is maybe 7-8 years old. So it's not been long in my mind. It's not been long. But really, even then, we're constantly having to review and make sure that those regulatory frameworks are fit for purpose, that they can keep pace with technological development as well. And so for me, I see as someone who is both a policy and involved in setting regulatory frameworks or responsible for them, I really see the value in those, and the need to do it with international partners is just so crucial. The way missions are becoming much more complex, crossing boundaries, jurisdictions, we need to find a way to support those sorts of collaborations and missions and ensure that the regulatory frameworks can support that. So one example, the UK signed an arrangement with New Zealand on rendezvous proximity operations. Again, really innovative missions, but actually what we really need is a set of basic principles of how we're going to work together, how we're going to either mutually recognize each other's frameworks. Licensing is another one. You know, there are very different licensing regimes across the world. How can we make sure there's interoperability? How can we make sure that we can recognize and support those missions as well? So yes, crucially important, but also just remembering like some of the things that have come into place happened before a huge expansion in commercial actors coming into space, and we need to adapt and evolve that. From my perspective, it's not about creating more burdens, it's about innovative regulation. That's what we're particularly trying to push in the UK.
Okay. So, I mean, I think perhaps from a commercial, so maybe Morris can comment, from a commercial company trying to work within these frameworks, so what do you need to see for collaboration on regulatory?
Well, all right. Yeah, it's also depend on the domains. For example, I think communication is more technical, and that's relatively easy. Like, you know, it's a bit slightly technical, like CCS, DS. There's several, you know, like a satellite communication, like standards, global, and, you know, it's like a lot of European nations are in it. So those definitely helps. And even for optical communication, those standards are trying to adopt as well. But if I may speak some other domains like launch, etc., well, I think the speed or, you know, review maybe usually the topic of a discussion in Japan or even US, definitely, and UK as well, I think. Yeah, I think commercial companies, especially like a startup like us, like, you know, smaller companies need to move quickly, you know, and if we have to be agile, if, you know, market demand changes, we have to adapt. And, you know, we want speed, but, you know, in order to do the business, definitely we have to comply with the regulation. And, you know, if if we wait too much, we cannot survive. I think those are usually one of the like, issues, or, you know, startups have, not only in Japan, I think.
Okay. Maybe Ian, can you comment from your perspective on regulations, regulatory frameworks, and also, I mean, where, for example, are certain countries looking at sandboxes to help speed things up, or how are things going?
I believe the UK may have a sandbox or two. Yeah. So sandbox is a maybe I'd let Tania explain.
Do you want me? Bring out my inner sandbox nerd. So sandbox is very much a safe space. It started in financial services, actually. It's a safe space to test the regulatory framework. So in the UK, what we're doing, we're working with industry, with our regulator, with government departments to stress test the UK regulatory framework for RPO missions. So originally, as I talked about, you know, missions becoming more innovative, more complex, what it does is it doesn't affect the market. You can do it kind of to the side or in parallel in a way that will identify, right, where is the friction, where are the challenges, and how can we best improve it. So I think we're one of 2 countries to have done a regulatory sandbox in space. We've done one on RPO. We'd like to do more, subject to budget. That's my 1-minute explanation.
Yeah, so a tool that can help, right, make regulation, try to be more innovative, give industry a role to engage in regulatory formation in a way that is collaborative, right? So I think from our standpoint in Secure World as an NGO that kind of looks internationally, a couple of challenges that we see. One is just the efficiency of regulation and policymaking is really challenged right now, given the rate at which cool things are being done in industry in a lot of different domains, right? It's industry wants to innovate, industry wants to move fast, industry wants to press advantage and gain, you know, position, right? And government wants to allow industry to do those things, but it wants to uphold international obligations as well and recognize, you know, liability and safety and all of the public roles that government has. And it's really to maintain that balance and to allow those industry activities to happen while keeping the regulatory system moving forward is a challenge I think a lot of states are seeing right now. And part of that challenge is, what is the role of industry in informing and setting regulation, right? Government has the mission and the requirement to set regulation, but industry has a lot of the technical expertise right now. Industry is the one conducting a lot of the operations right now. So how do you bring that technical expertise, that actual operational expertise into regulation? Sandboxes are a tool to do that. We see a lot of states, a lot of governments moving towards standards-based regulation. You mentioned standards, right? Industry has a role in developing standards. So one of the groups we have been involved in the secure world is an international organization called CONFERS, which is developing standards and best practices for satellite servicing, upgrading, maintenance, refueling, those sorts of things. It's a collaborative environment. It's I think 85 different companies from, I think, about 20 different countries right now, and it's put out a number of standards. And we've seen governments refer to those standards in regulations. So New Zealand, for example, has built a regulatory structure for RPO activities. You mentioned the collaboration with the UK, but the CONFERS standards are actually reflected in the New Zealand domestic regulation. We've seen that in other areas. So it's kind of a long, convoluted story, but it's bringing industry expertise into a process that governments then can use to inform and develop regulation. I think we're seeing approaches to that right now.
Thank you. Maybe Wakata-san, well, you've made the transition from government to industry. Where do you see, in wearing both hats, how has regulatory frameworks affected your perspective on things?
Yes, very good question. I really like Tania's innovative regulation or regulatory sandbox. Those are very fundamental functions for like a thriving space economy with that will facilitate the cross-border collaboration. I had a privilege to work on the ISS program, International Space Station program, and the first module was launched in 1998, and with the first crew launched in 2000. So more than 5 years, we had permanent human presence, and it's a technological marvel. But at the same time, looking back, I think this intergovernmental agreement, the backbone of the legal existence of the space station, that's a marvel. Because we have encountered a lot of technical issues like accidents and also geopolitical issues among the countries that are part of that. But we survived thanks to the intergovernmental agreement. It's a very powerful system for us to continue to work. ISS will be coming to an end in a few years, but now I'm switching from the government type activities to commercial. I think in order for us to thrive the economy in space, in the human space program, we need to have this adaptive, or I would say, as Tania said, innovative framework. So the new frameworks have to be flexible and adaptive in order to incorporate the needs of the industry. And time is ticking because ISS will be over in a few years. But I think it's very important for all the countries that are involved in ISS to continue the seamless utilization of the low Earth orbit, because there are other space stations around, and we need to continue to do that. So in order for us to continue that, we need to have a legal framework that is adaptive and that is innovative.
Thank you. Yamamoto-san, maybe you can comment on legal frameworks and how they impact your business.
I think everyone commented, but I think in terms of telecom regulation, those has been done quite well. We have accumulated knowledge of collaborating, and a lot of clever people has been for instance, in ITUs, standardizations. Those has been a great job. But one of the comment may be that the addressing the debris issue, that I think there's a lot of rooms to improve. I'm very happy that companies like Astroscale, Orbital Lasers, those commercial entities are already trying to tackle those issues, but I'm not sure governments, international-wise, are up to those to support them or have certain regulatory frameworks to address those issues. So, yeah, that's my comment, I guess.
So, Morris-san, you were smiling there. What was there?
Yeah, want to know.
Okay, yes. Okay, yeah.
He wants to know.
Okay.
So the challenge here is to not take the next half hour to talk about. This is an area that we work on a lot. So, so the space debris question is a really interesting economic and policy challenge. I'm not even going to say technical challenge, economic and policy challenge right now, because essentially you have two problems with debris. You have the existing objects that governments have left behind, the U.S. government being one of them, the Russian and Chinese being the other two big ones, European and others, so Japanese a little less. And then you have new activity that industry is doing, and how do you mitigate not creating debris from that activity? And those are two really separate problem sets. Astroscale, clear space, orbital lasers, they're doing great work. I do have questions about the business model, right? What are the customers to pay for removal of large objects? Thank you to the UK for some leadership, JAXA for some leadership. But those technology demonstration missions, those are good, but how do you scale that into a commercial business? And are governments going to be willing to pay to remove their large object? I don't know about that. And then does that technology that you develop for these large objects, does that apply to the satellite constellations and the new activity? Is an entirely different business and operations model? And will those operators commercially, they say they're designing for reliability in deorbit. They say they're going to deorbit their constellations at 5 years and replace them. If that fails, are they willing to pay to remove failed satellites? That's a really big question right now. And are they willing to do that at a price that makes sense for the commercial companies? So glad to see the technology, glad to see the interest, glad to see some policy leadership, but I think there are real big economic and business model questions around some of those activities.
If I could come back in. So I think it's debris is such a significant problem. It kind of needs so many different contributing factors. So you need to invest in the technologies. You need to be engaging diplomatically, internationally with countries, existing space nations, emerging space nations around norms of behavior as well. And these companies, as they begin to grow, and I think it's really exciting, also the potential into the wider ISAM market as well. You're right, there's the kind of business model as well. So there's so many, it's so multifaceted, I suppose, is what I'm saying. And I think we're really pleased in the UK to have that kind of flexible outcomes-based regime that has attracted companies like Astroscale. But again, it comes back to the international partnership piece for me.
Okay. Sorry, Ian, you're going to say...
Just a real quick one. And part of that is, can a Japanese company go approach a European objects and remove that? And how do we have that mutual recognition to do that, right?
Yeah, okay. I don't know, Wakata-san, whether you have any comments on that whole area of space debris and how you collaborate to manage it.
Yeah, I totally agree. I mean, it's very critical for us to live on the station, as I mentioned, that number of debris avoidance matters is increasing. And it's very critical. So far, nobody has been killed from a debris attack. I mean, debris hit to human assets yet. But I think it's just a matter of time. Because when you spacewalk outside on the handrails, there are a bunch of those debris hit areas. And we were told not to touch it, because if you scrape with your glove, then it's going to have a hole, and then you will lose oxygen. So we have to be careful. And then since we avoid those maneuvers, it's a matter of life and death.
Yeah.
And so I think, but I totally agree with Ian. How do you scale this, and who's going to fund this? And of course, it's a wonderful principle, but how do you make money out of this? Is a very critical, I think, a challenge. So I think, as Tania was saying, I think this international awareness agreement towards the goal of it, how to mitigate, I think we just keep discussing it, because I don't think it's an easy solution on this one, especially from economical and from a governmental standpoint.
Okay. I think if you look at space in the other dimension, so you've got GEO, MEO, LEO, and HAPS. Obviously, Space Compass, you're involved in HAPS, for example. So you don't have the same problems with HAPS platforms, for example. How does this problem scale for you? Where's the big problem for HAPS? It won't be space debris. What will be the challenges in those areas, for example?
So yeah, I think the technology we have a technology been there for many years, and I think our company is to take on a challenge to make that commercially feasible. Making that sustainable economically. So that's our missions, and so that's why we are on finding a right technology globally and with this international collaborations. And I have to say, I mean, international collaborations sounds very nice, right? But it's also at the same time it's extremely hard. I mean, I've been done a lot of international deals, commercial deals, but you have to always have to make a painful compromise. You have to make a lot of risk. Of course, there's a geographical difference, time difference, cultural difference. So those, but we can't stick to the domestic, or it's a space. It's a space. We can't. It's not a big market, right? It's telecom market is not. Space is still small compared to terrestrial network. It's like a couple percent. And we can't live with like sticking to the domestic market, or we have to find the best technology out there in the market globally, and we have to collaborate. That's inevitable. But at the same time, the international collaboration, it's not easy. It's really hard.
Yeah, maybe Morris-san, you want to comment on?
Sure. Well, not about hubs, but
Generally, yeah.
Well, yeah, I totally agree with him. But international collaboration wise, I understand that standardization. It means interoperability is standard, which means everyone has to compromise. Yeah. Some for example, different people cannot differentiate too much in that way. If we rephrase. So if I speak about optical communication as warp space, definitely there's several standards, and each standards for example U.S. standards called SDA. Their standard is good for their application, especially for the DoD, for example. Mm-hmm. The European one as well, they're good for their governmental constellation. Or Japan, we'll see, but. So I totally understand the issue. It's like a standardization definitely important to talk with other nations, in order to work together. But sometimes each nation have to compromise or cut off some of the functions. But probably it's for SATCOM it's been done and it's been alright, but if it's a more complicated solutions like a human space, etc., I think it's getting more difficult. And I know more experts are working on more detailed problems, especially for human space, because something to do with the human life. Definitely, compromise is not tolerated, right? Yeah, but that's what I thought on.
So if you look at that collaboration piece, you mentioned it's difficult. So why not do more within, say, Japan or within the US or within Europe? Why the need to collaborate? What's driving that? Maybe Yamamura-san, you were going to comment?
Yeah, so you.
Sure. I mean, space in the space industry. I mean, the collaboration is essential both in supply side and demand side. The demand, when we look at the demand side, once you launch a satellite, it's a global, borderless, right? You have to approach globally to make the business feasible. I mean, you can't just serve more market. It's maybe in 20, 30 years before that was possible, but it's no longer, especially given the big constellation project going on. I think that's we have to. It's not like we want to, but we have to, and especially both on the supply side as well. We can't just simply rely on domestic technology. We have to make sure we deliver the best technology in the market, and yeah, I think that's what we're working on.
Tania?
Yeah, I mean, I think. It's an interesting question, isn't it? I mean, international collaboration, what does that give you? I mean, that helps you de-risk technology, that helps you reduce costs, share learning. There will always be things in nations and countries, that, particular capabilities that they want to be sovereign. That's well understood, I think. But the idea that you would only have sovereign and lack that diversity, there will also be capabilities that you want to access or you want to collaborate with international partners as well. And so really international collaboration really drives innovation, right? Technological development as well, and enables you to reach a scale that on your own you cannot achieve as a single nation as well.
Okay. Ian, do you want to?
Yeah, I mean, to add to what Tania says, I think we say sovereign interest can even drive collaboration as well, right? If you look at some of the security collaborations that we see that are done for strategic interests and to counter adversary nations, but it is cooperation even in that context, right? So I think I would add to the list, Tania, political resilience in programs, like cooperation, especially in big international exploration or space science programs, helps you build a political support for a program that goes outside of an individual nation and can help sustain a program. And maybe I'm influenced by current volatility back home, but can help sustain a program across volatile times in government. So I think that's, from a government standpoint, is something that's important as well. From industry, right? I think hitting the market drivers that you were talking about, the supply chain and inherent internationalism, a lot of space projects, right? I think those are the main factors there. And then the last thing I would say, again, coming back to a governmental perspective, cooperation helps you promote the values, norms that you want to see the guide the development of an industry or sector, right? So collaboration is a tool to promote your vision of a government as a government, or your ideals as a government with your partners and with those that you work for.
Yeah, I think that's an interesting point about the political will to sustain these programs, because these programs are long term. I mean, so for Axiom Space, I mean, what is your time window for the new space station? I mean, how long will it take for you to develop and deploy?
Right, so we have to launch and deploy the new space station components before the ISS is over. So our first module, payload power thermal system module, will be launched in 2027 before 2030, and that's our plan. And so by the time we have ISS decommissioning, we will have a human capability, and that's going to happen in a few years. Time is ticking, but as I mentioned earlier, it's important to have the seamless transition from the ISS to the commercial LEO destination. So, but this period of 5 years, 4 years of what's called the bridge is very critical. We have a contract with NASA to attach a commercially developed module to the International Space Station. We are the only private company that the NASA is contracted with. So this bridge period is important because on the ISS, we have very precious experiments on the multi-segments of the International Space Station. When the station goes down to the Pacific Ocean, we will lose everything. But by having a module that will be attached to the ISS, we can deliver those important, very precious equipment to our module. And then once the ISS is decommissioned, then we will continue to grow. So I think this bridge is very important. And going back to the international collaboration, I agree with everybody. And I think it boils down to this economic resilience and sustainability. It doesn't seem to be that collaborating is leading directly to the sustainability, but in the long run, it will. So I would say if you want to go fast, do it alone. But if you want to go further, do it together. And I think that really boils down to that. And you can see this in the commercial programs and the governmental programs. And because the challenges, technical or political, geopolitical challenges are huge, in order to overcome that, I think it makes sense to collaborate in the long run.
Right. And then what are the enablers for that collaboration? So what kind of partners do you look for when you're doing this? Maybe Maurice, and you can start on that one.
Well, as a commercial company, think most of commercial companies start with more technical, match, right? Yep. Because most of the commercial company have a certain business, and especially like space companies are like one of the deep tech, technology driven. So also we need to see the market demand as well. So for example, optical communication, we try to see subsystem for like lasers, amplifier, etc. Then we since we now international, we don't necessarily prioritize international collaboration, but in order to find a top technology, it's gonna be global anyway. So that's why we have the US or European office. So yeah, come back to your questions. It's like usually technical match. Yeah,
Technical match.
right.
Maybe Yamamoto-san, what are you looking for in partners in what you do?
I think finding partners, again, space industry is not really big. I mean, I feel it's not like a consumer product or it's there's not a lot of people. It has been grown a lot recently, but I mean, especially like people like Mori-san knows everyone in the industry. It's not really difficult to find the right people. I mean, so I don't know if I answered it.
Yeah, no, it's fine. Yeah, I understand. Yeah, so the partnership thing to a certain extent is a small industry.
Right.
Therefore, we all need to work together.
Yeah.
To a certain extent. Yeah. Okay. In terms of one of the things that came up earlier is there's these various new emerging areas such as in orbit, servicing, manufacturing. Where will those technologies come from? How will they develop? That's an interesting thing for me. If you think about those technologies, which will emerge most earliest? Ian, you're gonna.
Ask the nonprofit guy which industry is going to.
But by the way, when we started this panel, I promised not to get into technology, but but then you did bring in the topic, so I thought I would ask about it.
So I think we're seeing on-orbit servicing that's emerging now, right?
Yep.
We're seeing companies that have done commercial to commercial B2B deals to refuel or extend the lifetime of satellites, right? So we're seeing initial market uptake on that, and we're seeing strong interest from governments, in particular on the national security side, but from both civil and security side governments in that capability, right? So I think there is a demonstrated need for satellite life extension and refueling, and then that will begin to open up some of the other parts of that convoluted ISAM acronym and on the assembly manufacturing side of things. Wakata-san is a much more place to talk about commercial space, commercial human space flight and space stations than I am. Clearly the large LEO constellations are a legitimate new market driven both by commercial and end use and governmental institutional use. So that is clearly a viable thing, even if you step outside of Starlink. And I think there is, Susan mentioned SDA and commercial space situational awareness. I think there is a limited market for that outside of government. So governments are going to continue to buy space situational awareness data for space safety, but basic public function. But commercial operators have need for this data for safety purposes, for doing more exquisite, more unique activities, such as satellite servicing, such as docking with space stations, right? So I think there's a market for some commercial space situational awareness activities.
Okay. What about Earth observation? As where's that going to go? You mentioned the AI at the edge. How quickly will that evolve? Will AI in space? Perhaps Yamamoto-san.
My personal impression is that it's much faster than we think. I mean, the recent AI development has been in ground.
Yep.
It's been tremendous. I'm sure it's going to be the space computing performance has been increasing rapidly in space as well. Space represented by ISS, and also in space as well. The space computing technology in 10 years back, it was like much low tech than iPhone, but now it's getting really tipping off. So, yeah, I think it's going to be quick.
Wakata-san, what do you see in terms of technology you'd like to see in space emerging to enable your kind of missions?
Yeah, so I can speak for, in terms of a human space flight and utilization of low Earth orbit. We have like 40 years or longer, time of experience of utilizing space for a lot of experiments. Space shuttle, space station, and even the Russian space station Mir acquired a variety of data. What does zero gravity do for us? And those are supported by the government. So there were a lot of experiments, probably that did not lead to any economic effects, but the fundamental science type experiments. But as a result, we have a plethora of data that could be utilized for money making in a business. That's why we are focusing on like a semiconductor, pharmaceuticals, and also like producing artificial organs, for example, with additive manufacturing. So all of these areas, did not happen today, but because of the, long-term, few decades or longer decades of experience on the station and the shuttle and the Mir station, we are able to now focus on those areas that could potentially benefit economically. And that's why for human space flight, the low Earth orbit is a very critical field. Of course, we are talking about the Moon and Mars mission, but if we cannot economize LEO for human space flight, because of the cost to launch humans to further space, I don't think it's going to be lucrative in the beginning at all. So that's why the LEO utilization to economize is a very critical situation. And this is a time to do it because the ISS will be over in a few years. So that's why we are focusing on those specific areas, semiconductor, pharmaceuticals, artificial intestines, and stuff like that, and orbital data center. That could be the foundation of LEO utilization.
And as an industry, we need to tell that story to the people so that they see the benefit of space flight. Is that fair?
Yes.
Yeah.
Yes. Thank you.
Yeah. Okay. So if we look to the next 5 years, maybe we'll finish on the main questions now. Look to the next 5 years. What would you like to see? So maybe we'll start again. Morris, and work down the panel.
Sure, yeah. But definitely, as a warp space, optical communication, actually it's being more commercialized. Some companies are making hundreds of terminals, and I think the shift from RF to optical communication is happening now. But in the next 3 to 5 years, I think I wouldn't say majority, but some of the at least some of the major constellations will probably have a capability, include not just between satellites, but space to ground as well. There's several people actually commercially building optical ground station and putting on some areas, try to mitigate atmospheric dissipation. And it's actually demonstration is done actually first half of this year. I think if development goes well, then this year or next year, more and more space to ground optical communication, like 10, 100 gigabit per second, is available, which is comparable to submersible cable, for example. So we could have further application to some of the areas in Africa, etc., to connect. And the speed is comparable to submersible cable. Could happen within 5 years.
Yes.
Yeah.
And so resilience of global networks becomes quite impressive.
Right.
Ian, the next 5 years?
Yeah. So
Yeah, is it?
Ian learning how to use a microphone. We'll put that in the next 5 years. So I'll put three things. We haven't talked much about space traffic coordination in this session, and we don't need to, but I would like in the next 5 years that we have multiple national systems for sharing space safety information with operators, and then an international level in which those things are coordinated. So space traffic coordination done at the national level, but with a multilateral framework on top of it. So that's number one. Number two, I think we're on this path. I would like to see multiple commercial satellite servicing ventures offering services on a commercial availability with multiple customers. So the emergence of a functional marketplace in satellite servicing, which then enables another set of activities to follow that. So that's 1 and 2. Those are more technology or policy. And then number 3, I would like to see the space sector, our companies, our operators, more effectively engaging with the end user community to talk about the benefit of what we're doing and the services that we're providing.
Okay, thank you.
Yeah.
Tania.
Ian, you stole 2 of my 3. So yeah, space traffic management coordination was one I was going to raise because there isn't that multilateral framework for it, and we will need it more and more. And I think the multilateral collaboration between countries at the UN and other fora, I would like to see really progress. I think from a UK perspective, there are specific capability areas we really want to develop: launch capability, space domain awareness. We're starting ISAM, as Ian said. We're starting to see this emerging potential market with end-of-life extension, refueling, but really the future potential for assembly and manufacturing for me is very exciting. Yeah, and we've got a company in the UK that is planning to manufacture semiconductors in space. So huge potential. And really just we go back to regulation as well, I'd go back to, which is the work collaboratively to look at how we recognize, align, coordinate on standards and regulations to really support the really future innovative multi-state missions as well.
Okay, thank you. Wakata-san.
Yes. So next 5 years is a very critical period of time for human spaceflight, as I mentioned multiple times, because of the transition from the government-led International Space Station program to the commercially led LEO destination. So the bridge period is very critical. And our goal is to have a sustainable commercial platform. And the goal is not to benefit the industry, but the goal has to be a benefit to the humanity, in general. Yep. So that's why I think we have to focus on those, areas that we can utilize the microgravity for the benefit of humanity, like including this semiconductor business and then the in-space manufacturing. Yep. And not only experimenting, but that we need to have a space foundry so that we can produce a large amount, of this semiconductor and then other materials that can only be made in space, considering the cost of transportation. And that's how we make LEO utilization monetize, I think. So this is the goal, to have a sustainable commercial platform. This is the goal in the next 5 years.
Okay, thank you. Yamamoto-san.
Yeah, as I mentioned, the data explosion, space data explosion, has driven the market significantly. And I think it's in a tipping point where we see those data becoming value, and I think those really the demand or the value that really drives international perhaps forces the international collaboration. And I think the traditionally the telecom, there was a huge demand in international space telecommunications. Satellite communication has been played important roles. And that demand really made us, force us to make international collaborations and use of our limited space resources equitably with a regulation. So I think the upcoming exploding demand or the value that we as an industry going to bring, that I think is going to really lead to changes the dynamics or probably augment the international collaboration. So I'm very optimistic and happy to.
Do you think there will be surprises? So in 5 years' time, will there be use cases you can't imagine, or that will become?
I'm sure, there is.
Will that be what happens? Do you think?
Yeah.
The other thing I should come back to, if that's okay, Miles, is just mainstreaming space. So it's not seen as a sort of separate thing to other things. Really mainstreaming space. That's what we do in government in the UK. That's what we're trying to do, again, with the sector and with the economy as well, and for commercial players.
Yeah. To Ian's point, and to other people's point, making it feel just a normal part of business. It's one of the other it's just another aspect of industry, effectively. Yeah. So we've had, by the way, thank you very much. People have already asked a lot of questions online. So please, we'll now move to Q&A. So please, if you want to ask questions, there's a QR code there. So I'll actually start with a very pertinent question. So some anonymous person has asked about the West Texas flooding disaster. as an example of how could space have helped avert that, but also help with disaster recovery. And I think a number of people could comment on that. Maybe Yamamoto-san, from a communications perspective, how would that have played into?
Yeah, I think that I haven't talked about HAPS technology, and I think the stratosphere hasn't been used just like space 50 years ago. Stratosphere is somewhat the place where no one has used before. So it was just the way through the space. It was just a small space. But now I think the technology has been demonstrated that we can use that stratospheric space where you utilize that space. And the Space Compass is working with Airbus subsidiary Alto to utilize that stratospheric space to tackle those natural disasters issues. And one of the HAPS advantage is very unlike space. In space, you have to launch it, manufacture it, launch it, design. Which could take a couple of years. But HAPS, you can launch it in like a couple of days, perhaps, and that's which could accelerate our innovations. And we see a huge potential providing emergency communications, remote sensing, data, and delivering the right communication or the data to the right people. So we're very excited about it.
Tania.
Yeah, I just wanted to, with the flooding, obviously very, very relevant at the moment. So the use of space for weather forecasting, really important role. How can we get more accurate forecasts in place? Connectivity is the second one, as been raised, which is how do we ensure connectivity when things go down, when we're in kind of emergency response mode. And then Earth observation to ensure the kind of continual monitoring of how the situation changes. So a really critical role, I think, for space in those disaster prevention and management response as well.
Any other comments? Ian?
Yeah, I mean, it's obviously a situation there still unfolding. I think we don't quite know the extent of the loss. It's Tania's point, right? I think there is the role of weather forecasting, the role of space data in weather forecasting that could have led to more information before the event and early warning, and making the case for maintaining public investment in those systems and making sure that that data is available to the forecasters and to the first responders on the ground. And then there's the after the event occurs and how you use space to recover, respond, and assess. And believe the International Charter on Space and Major Disasters is still a very functional enterprise, and probably has not been used for this, but ways that we cooperate to provide Earth observation data after an event and make sure that it gets to end use. I think events like this call that to attention.
Okay. So we have another question saying the space businesses are often initiated by startups, and then scale up is difficult, small business and difficult for investment, etc. So how can people better make the transition from startup to large scale? And maybe that's a very good question for Mori-san, and maybe Wakata-san can comment from another perspective.
Well, if we know the answer, it's easy.
True.
Anyone does that, right? Everyone does IPO in 3 years. Well, but it's quite, it's not, seriously, no one really knows a perfect answer. But in order to scale up quickly, since I'm just a Japanese company, if I talk about the Japanese situation, compared to US, for example, I think the initial risk takers is usually relatively more governmental than private, for example. Yeah. So government relations, capability may be relatively more important, for example, in Japan, to kick off, to get the initial speed. Then, obviously, it's not, we have to do the business, so we have to get the commercial demand, etc. We have to somehow find diversified exit way to find out making a more revenue. And this is very conceptual, but I see that this concept more this theory is not operated in much in Japan, I think, and this governmental relation capability by startups could be reinforced in order for Japanese startups to go scale faster. Yeah.
Any other? So
if I look at UK as an example, we have lots of SMEs, lots of startups in the UK. The ecosystem there really strong, something we're very proud of. We recognise the challenge of those startups to really scale up. So what historically we have done is put a lot of R&D grant funding at the kind of low TRL levels, the seed funding as well. What we've recognised in our industrial strategy we published not very long ago is really the need for other types of investment to really scale up. So space has been recognised as a frontier industry in that industrial strategy for delivering economic growth. And what that means is access to finance. So a different colour of money is how we talk in government to enable those companies, space companies, to scale up. So they'll have access to things like a national wealth fund, the British Business Bank, in the way historically that perhaps hasn't happened. I think the other thing in the UK we try and do is really use, obviously we don't have huge budgets on space, but use that public funding as a way to help leverage private investment. And that is one of the strengths for the UK in particular to help startups as well. So those are some of the examples of interventions, I suppose, to help support scale up.
So, Wakata, maybe you can comment from a Japanese perspective. Is JAXA doing the same thing, trying to catalyze the private sector through public sector money?
Yeah, I think so. I cannot speak for JAXA anymore, but I think many countries, including Japan, UK, US, I think the key is the public-private partnership. I think it's the key, especially for human spaceflight. The risks are huge, and there are a lot of technical challenges we have to overcome. So this 10-year Japan's space strategy fund is an enabler. For those companies, especially the startup companies, to play a major role in the various fields of space activities. Human spaceflight is also very important in this space strategy fund. I think UK is doing a similar thing, and I think it's important not only this private partnership collaboration within a country, but also internationally. International collaboration between the companies, but the companies supported by the government will benefit a lot. And then human space flight in the Axiom activities, one example, we have strong private public partnership with the US government. And at the same time, we have been flying international astronauts, the first astronauts from Saudi Arabia to the ISS, for example. First astronaut from Turkey, first astronaut to the ISS from Poland, Hungary, and India. And so this government support of human space flight plays a key role. And I think it's important at this time for a human's presence in the low Earth orbit and beyond to have this public support.
Okay. Yeah, you can say.
Yeah. No. So public support toward the startup has been I think improved a lot in space industry, and but I guess. I guess the key is maybe Tania touched upon, but are we investing in technology or the value or the demand? I mean, so strategic funding is Japanese strategic funding is I think I'm very happy about it as a space industry person, but I think it's still focused perhaps too much on technology, and are we really delivering value to the society or the people? And I think the key you touched upon. I think we should much more invest on the value or the business itself, which makes that really sustainable and grow, and focused on the demand rather than the technology. I think that's the key.
Okay. So there's a couple of related technology questions come in. So combining space networks with terrestrial networks is a theme people are asking about. but combining space data with terrestrial data, how to make use cases that are beneficial from the combination of both space and terrestrial. So anybody want to comment on those areas? Everybody's looking mystified.
Yeah, no, I'm just a repeat of what I said. So, data center, there's, I don't know, gigantic number of orbital data centers on the ground, but by having this orbital asset that serves as a backup for the resiliency to cope with potential attacks, cyber attacks, and real-time decision or faster time decision by having this computer with AI and the machine, learning capabilities. And so I think backup and the resilience is the key to have an asset on board, on orbit.
Yeah, the only thing I was going to add there was, as you mentioned, like one of the things we've been looking at is exactly that, integrating our kind of telecoms and satcom strategy.
Yep.
As we look to data increasingly, I think it's a very similar opportunity there to look at that and really indicate making sure we've got the data architecture to be able to facilitate that as well. And really looking at kind of how we use that data, whether it's an integrated terrestrial space or otherwise, as well, even across the public sector in the UK. Is there a better way in which we can procure and use that data as well?
And then on the industry side, I think it goes back to understand the customers, talk to them about what they need and the services they're looking for, and less about the technology, right? So if you're talking to somebody in agriculture, they may not care that the data comes from a satellite versus a HAPS versus a person within a truck with a camera, right? But they care about the use case and what value it brings to them.
So does that imply there'll be a need for abstraction? So basically, people need common interfaces so that the use cases on the ground can become quite open. Would that be a fair way to put it? So to your point, nobody cares where the data come from. You've got an internet of space that just delivers you data. Is that what you need to get to, do you think?
Yeah, I mean, go ahead. Seamless networks, connecting terrestrial networks and NTN are one of our missions.
Right.
You is working on that he's from GSAT, but he's working on that as well. But I think it's really important.
Good. So I think we have a lot more questions. Sorry, I haven't been able to ask many of them. We're almost at the end of the session. So any final comments, perhaps Yamamoto-san, and we'll go down the panel?
Yeah. Sorry. I'm getting used to it. But yeah, it was very interesting to see everyone talks. Very fun to talk to learn about a lot of things with the panelists here today. But I think international collaboration is it's hard, but it's also fun things. Visiting people's and seeing new people it's a life enjoyment to for all of us, and we're happy to continue that. Thank you.
Wakata-san, final comments.
Yes, I echo Yamamoto-san. International collaboration in that industry level is very critical, especially with the non-space type industry. We are building a new spacesuit for spacewalking on the surface of the moon. We're working with Italian fashion designer company Clara, and also from the communication standpoint, between the spacesuit to the human landing system, we are working with Nokia for the 4G LTE system. And I think this commercial-led development allow us to work internationally between the companies and the industry level, not only government level. And I think it's probably faster and more economic and creative. So I hope to see more participants from Japan and the UK and many more countries for effort in human space exploration.
Thank you. Tania?
Yeah, it's in conclusion, I suppose, space is a shared resource. It's a shared domain Ian was talking about. And I think if it becomes unusable, that's a problem for all of us. I think that's a real thing to focus on, as whether we're talking about technologies or the political, diplomatic engagement as well. And for me, that international collaboration clearly demonstrated here is important, both for government, international collaboration, industry, academia, non-government organisations as well. We need all to be pursuing those partnerships. Really, that's my key takeaway.
Okay. And now you've stolen what I was going to I was going to say, Tania. So I'll pick up another one. We talked at the beginning of the panel about how space is becoming more complex. We're seeing more commercial activity. We're seeing more pace of innovation. We're seeing a lot more new applications. As space becomes this more commercially driven, private sector driven domain, I think it really puts pressure on us in the community and in industry to clearly communicate the benefit of what we're doing and how that enables broader societal use and good, right? And not let the message become this is a commercially extractive activity, right? To really focus on that benefit conversation.
Well, I think it's been a lot of between commercials, not just UK and Japan. There are many commercial collaborations happening last 3 to 5 years. I think this trend will increase. And for example, Warps has been working more Australian, US, German, Finnish companies. And since I forgot to tell that I have a lot of personal connection to UK as well. I used to actually study in the Cambridge, and it's actually this is one of the reasons I think Cambridge consultant came here as well. And I think this change is already one of the evidence that now Cambridge consultant came. My old friends kind of came to Japan and trying to encourage more collaborations. I think this kind of trend should increase and promote more collaborations, right? Yeah. Hopefully peaceful ones.
Yeah. Okay. Well, thank you very much to our panel. We're now going to have some closing remarks by Ishiga-san, but I would like to first of all have a round of applause and thank you very much for our panel.
Great.